Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 3. Shift symmetry as formal invariance. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We are in Ep.8, the pure abstract language, where we are examining the holophase language in its essence, before it writes any physical universe. In part 1, we began this abstract journey by meeting phi as a pure mathematical creature, not yet a physical field, but a structure that could become one. In part 2, we explored phi as pure potential, the silent alphabet, the blank page ready to receive meaning, but not yet speaking. We learn to see phi not as a thing doing something, but as the capacity for every possible pattern that could ever unfold. Today, in part 3, we discover something fundamental about this language. It does not care where we put zero. The language only cares about differences, not about absolute values. Today, we meet shift symmetry, the beautiful, quiet principle that adding the same constant to phi everywhere changes nothing meaningful at all. This is not yet physics, not yet gauge symmetry in its full physical form. This is a purely linguistic property, a feature of the abstract language itself before the language is used to write any world. I want you to feel this, not just as a sentence you hear once and forget, but as a new habit of perception. So let us walk through it slowly, in simple images, with concrete examples, until your intuition begins to say, of course, it could not be any other way. Imagine you are standing on a vast, empty plain that stretches to the horizon in every direction. There are no mountains, no buildings, no roads, nothing at all to mark one place from another. You decide to make a map. To do that, you choose one spot under your feet and declare, "This is my origin. This is zero." From that spot, you imagine a line pointing north, another pointing east, and you begin to give every other place coordinates measured from your chosen zero. Now pause and ask a very simple question. Did the world care which spot you chose as zero? If the plane is truly featureless and perfectly uniform, then the answer is no. You could have walked 1 kilometer in any direction, chosen that new spot as zero, and drawn your map again. All the distances between locations and all the directions from one point to another would be exactly the same as before. Only the labels on your map would change. This is shift symmetry in its simplest form. The choice of origin does not affect the structure. The relationships between points are real. The place where you write the symbol zero is a convention. Now let us make the landscape a little more interesting. Imagine that the plain has become a real country with rivers, hills, and valleys. You decide to draw a topographic map that shows the height of the land above some reference level. Again, you must make a choice. What do you call height zero? You might choose sea level. You might choose the deepest valley. You might even choose an arbitrary number in your notebook. No matter how you choose, something very important does not change. If one hill is 50 meters higher than the nearby valley, that fact stays true whether you call the valley 0 meters, 100 meters, or minus 20 meters. The contour lines on your map showing where the land rises and falls will look exactly the same. Rivers will still flow from higher regions to lower regions. The shape of the landscape is encoded in differences of height, not in the absolute number you write as zero. This is exactly what shift symmetry means for phi. Only differences in phi matter. The absolute value of phi at any one point has no independent meaning. You can slide the whole pattern up or down by a constant, and everything that can be observed remains unchanged. We can say the rule in a compact way. If we replace phi by phi plus a constant c everywhere, all meaningful structure is preserved. The peaks and valleys of the pattern, the oscillations and gradients and curvatures, all remain exactly as they were. Only the baseline moves. Think again of temperature. But now imagine you have a room filled with air. The actual air pressure in that room is large, but you do not feel that. Your ears and your skin respond to tiny differences in pressure as sound. In the same way, your sense of warmth responds not to some cosmic absolute temperature, but to differences in temperature between your body and the air. If London is 20 degrees and Paris is 25 degrees, the difference of 5 degrees is what matters for weather, comfort, and heat flow. If we decide to measure temperature in another scale, or even to redefine our zero point by a constant shift, the difference remains the same. The flow of heat, the behavior of storms, the chill you feel on your skin, all continue as before. The world did not change because we slid the number we called zero up or down. Phi is like this, but even more radical. With temperature, we can still talk about absolute zero as a special point where thermal motion stops. With phi, in the abstract language, there is no special absolute value at all. Phi takes values on a circle, and the circle has no privileged point. Where we decide to mark zero around that circle is entirely our choice. Let us translate this into the language metaphor which has been guiding us from the beginning of the Holophase journey. Shift symmetry is a kind of redundancy in the writing system. It means the same sentence can be written in different but equivalent ways, and the listener cannot tell which version was used. Imagine you write a sentence in all capitals and then write exactly the same sentence in all lowercase letters. The pixels on the screen are different, but the meaning you perceive when you read is the same. The difference in capitalization is a stylistic layer that does not change the story being told. Or imagine a poem translated very carefully from one language to another. The exact words, the sound, the rhythm change, but the deeper pattern of images and relationships and feelings can be preserved. A good translation reveals that there is an underlying meaning that is not tied to any one symbol set. Shift symmetry is even stricter than this. When we add a constant to phi, we do not just change the appearance of individual letters. We leave all the derivatives of phi unchanged. Every pattern built from those derivatives, every rhythm in time, every shape in space, every law of motion, every topological winding remains precisely the same. In that sense, adding a constant to phi is like changing the font of an entire book without altering a single word. The story itself stays identical. The language has built into it a freedom to choose a baseline that does not alter the content. Scientifically, we can express this in one sentence. The information content of phi is entirely in its variations, not in its absolute values. The language of reality cares about how phi changes, never about what number we choose as the starting point. To keep this intuitive, let us walk through a few everyday systems and see shift symmetry in action. Think again of sound waves in air. The atmospheric pressure at sea level is large, but your ears do not detect that static background. You hear only changes, the small compressions and rarefactions that ride on top of the baseline. If we could magically increase the baseline pressure everywhere in the room by a constant amount, but keep the tiny variations identical, the sound of music and speech would be unchanged. The orchestra would play, the singer would sing, and your body would respond exactly as before. The baseline moved. The pattern of differences did not. In electronics, what really matters for circuits is not absolute voltage, but voltage differences. A battery separates charge between its two terminals and thereby creates a difference. Components in the circuit respond to that difference. If you leave the entire circuit so that every point is 100 volts higher relative to the Earth, nothing about the currents inside the circuit changes, as long as the differences between points remain the same and insulation holds. Your phone, your computer, your lights, all care about relative voltages, not absolute ones. In gravity, water flows downhill. It flows from higher gravitational potential to lower gravitational potential. Suppose you could raise an entire landscape by exactly 1 meter without changing its shape. Rivers would still run along the same paths. Lakes would form in the same basins. The fact that a particular hill is 50 meters higher than the valley beside it does not depend on the arbitrary number you choose to call zero height. Phi encodes this relative way of thinking at the deepest level. Every derivative of phi, whether taken with respect to time or space, computes a difference. It asks how phi changes between one instant and the next, or between one location and another. Those differences are where meaning lives. To feel this in your body, let us return to music, which is one of the cleanest windows into shift symmetry. Picture a simple melody that you know well. You hum it quietly to yourself. Now imagine playing that melody, starting on a low note, and then again starting on a much higher note. Musicians say you are transposing the melody into a different key. To your ear, however, it is recognizably the same tune. The steps between notes, the pattern of rises and falls, the timing of pauses and accents all match. What defines the identity of the melody is the map of intervals, not the absolute pitch. You can slide the melody up and down the keyboard, and its character, its emotional flavor, survives. Now imagine a listener who cannot sense absolute pitch at all, only interval patterns. For that listener, any transposition of the melody would literally be the same experience. They would not just say it feels like the same tune, they would say it is the same tune. In our holophase picture, the universe is like that listener. All physical processes are sensitive only to derivatives of phi, to interval-like relationships around the circle of possible values. None of them are sensitive to the absolute angle we decide to call zero. So when we replace phi by phi plus a constant, we have simply transposed the melody in a musical universe that hears only relative pitch. Every physical ear continues to hear exactly the same song. Let us now view the symmetry through the lens of the three echoes: time, space, and motion. From the time perspective, shift symmetry says that if you add a constant to phi, the way phi changes over time does not change. The time derivative of a constant is zero, so the time derivative of phi stays the same. Frequencies, growth rates, decays, oscillations all depend only on how phi varies in time, not on what constant level it is sitting on. From the space perspective, the same logic holds. Spatial gradients measure how phi changes from place to place. Curvature tells us how quickly those gradients themselves change. Convergence and divergence tell us how patterns gather or spread. Add a constant everywhere, and every spatial difference stays the same. Gradients and curvature are blind to a uniform baseline. From the motion perspective, the laws that describe how patterns move are built from these time and space derivatives together. A wave propagates according to how steep the gradient is and how fast the field is changing in time. Because both pieces are shift invariant, the propagation law is shift invariant too. The path of a moving pattern, its speed, its direction, all remain identical when we slide phi by a constant. This harmony across all three echoes is deeply important. If shift symmetry were respected in time but not in space, we would have a language where temporal stories and spatial stories could not line up. You could have a description that looked consistent when you watched it over time, but inconsistent when you examined it across space. The fact that shift symmetry is honored by all three echoes tells us that time, space, and motion really are three views of the same underlying field. They are like three different ways of reading the same text. Where does this symmetry live in our master tree of derivatives? It lives right at the root. It is not another branch, it is a rule about what the root means. At the base of the tree, we have phi itself. From phi grow the first derivatives, omega as the time derivative, k as the space derivative, and the mixed change that combines them. From those branches grow higher derivatives, alpha as the change of omega, curvature as the change of k, and so on, up to the infinite canopy that gathers all possible local questions one can ask about how phi behaves. Shift symmetry says that if we slide the entire root around the circle of possible phi values, the whole branching structure above it remains unchanged. Every derivative pattern, every combination of derivatives, every tower in the tree stays precisely the same. The entire tree is built out of differences, so any uniform shift at the root passes straight through it, invisible. You can imagine drawing the tree on tracing paper, then sliding the paper left or right. The drawing does not change, only its position on your desk moves. Shift symmetry is this sliding freedom, but now applied to phi's values rather than to a picture on paper. Once we see this, we begin to understand how shift symmetry constrains everything that follows in the language. Omega, as we said, measures how phi changes in time. K measures how phi changes in space. Direct change and all higher-order derivatives are built from these. Topological features like winding numbers, where you count how many times phi wraps around the circle as you go around the loop, depend only on how phi changes along that loop, not on where you decide to start counting. Quadratic expressions that measure intensities of change depend on derivative squared and remain invariant when we shift phi. All of these neighbors in the language are perfectly compatible with shift symmetry. They are built to ignore the baseline. This suggests a powerful design rule. Any quantity that changes when we add a constant to phi cannot represent something physically measurable. It has no place in the dictionary of observables. Only expressions that survive this test of shift invariance are allowed to enter the final script of reality. You can think of shift symmetry as an internal quality control check that every proposed quantity must pass. You propose a new combination of phi and its derivatives as representing something real. The language asks, if I slide phi by a constant, does your quantity change? If the answer is yes, the proposal is rejected. If the answer is no, the proposal remains on the table and can be tested further. Now let us talk directly about falsifiability, because if we are going to lean on this symmetry, we must also be willing to let it go if nature contradicts it. Shift symmetry makes a clear and testable claim. There is no physical effect that depends on absolute phi values. Everything that can happen depends only on differences in phi and their derivatives. One way this could fail would be if we could build a phi meter, a device that reports an absolute phi value at each point, and if its readings were not simply reparameterizations of derivative information. If such a device existed, and if its output influenced other observables in a way that changed when we added a constant to phi, the symmetry would be broken. Another way it could fail would be if we discovered interactions whose strengths depended on phi being within particular absolute ranges, independent of derivatives. Imagine a hypothetical process that becomes suddenly stronger whenever phi lies between 1/4 and 1/2 of the circle, and weaker whenever phi lies between 3/4 and a full turn, with no corresponding change in gradients or time derivatives. That would be a direct violation of shift symmetry. Even if we never build a phi meter, mathematics itself could corner us. If we find families of patterns in our universe that simply cannot be produced by any shift-invariant combination of derivatives, then the pure shift-symmetric version of the Holophase language would be incomplete. We would have to extend or modify it. The important thing is that this symmetry is not a sacred belief. It is a working assumption, clearly stated and constantly open to challenge. That openness is what makes the Holophase framework scientific rather than dogmatic. If you want to see the technical side of how shift symmetry is encoded in equations and how it constrains later terms in the theory, you can search for Holophase on Zenodo, where the full mathematical treatments are archived. To deepen this, let us look briefly at shift symmetry through the lens of measurement itself. Whenever scientists design an experiment, they must decide what their instruments will actually read. A thermometer reads expansion of a liquid in a tube or a change in electrical resistance. A voltmeter reads the deflection of a needle or the digits on a screen. Behind these instruments, there is always a choice of where we set the dial to 0. Two laboratories can choose different zeros, use different units, and still agree on all of the physics, because every comparison they make, every graph they draw, uses differences on the vertical axis, not the raw position of 0. The same is true in data analysis. Imagine plotting a graph of some oscillating quantity over time. You could shift the whole plot up or down by adding a constant to all the data points. The visual rhythm of peaks and troughs would be unchanged. The measured period between peaks would be unchanged. The correlation of this pattern with another pattern would be unchanged. Only the baseline line on the graph would move. A scientist looking only at the relationships between curves would not even notice that the baseline had shifted. Another helpful angle is to see how our own senses are built around differences rather than absolutes. Your eyes adapt to brightness. When you walk from a dark room into bright sunlight, at first everything is washed out. But very quickly, your visual system resettles its internal zero so that you can again see contrasts. If you then walk back into the dark, the process happens in reverse. Your eyes are constantly shifting their baseline so that the useful information, the differences in light and color, stay in the comfortable range. Your ears do something similar with loudness. An orchestra warming up sounds loud at first, but after a few minutes, your brain treats that volume as the new normal. What stands out are the changes relative to that living baseline. Our nervous system is a biological implementation of this kind of symmetry. We can even see a shadow of this principle in language itself. Think of the tone of a conversation. Two people might speak very softly to each other or very loudly, yet the emotional content can be the same. What matters is not the absolute loudness, but changes in tone, emphasis, pauses, and rhythm. A gentle rise in volume can signal excitement or anger. A sudden drop can signal seriousness or intimacy. If you record a conversation and later increase the volume of the entire track by a fixed amount, you do not change its meaning. You only change how hard the speakers must work to be heard above background noise. Shift symmetry also invites a certain humility. It reminds us that many of the numbers we write down in science are partly choices of convenience rather than reflections of some sacred cosmic scale. We choose zero levels, unit systems, and reference frames because they make our equations tidy or our measurements straightforward. Shift symmetry tells us that underneath those choices, there is a deeper layer of description that does not depend on them. The holophase language lives at that deeper layer. It is written in relations that survive our arbitrary decisions. Finally, shift symmetry gives you a practical tool for thinking more clearly about any system you encounter. When you feel overwhelmed by details, you can ask, if I move the baseline of this whole situation up or down, what would actually change? That question helps you separate what is merely conventional from what is structurally real. In mathematics, in physics, in social life, and in your own inner experience, that separation is precious. It lets you focus attention on the patterns that truly matter, the ones that persist when the arbitrary choices are stripped away. From a philosophical point of view, shift symmetry whispers something deep about what it means for anything to exist. It suggests that being is not about isolated objects carrying fixed labels, but about webs of relation. You are not defined by an absolute number that could be stamped on your forehead. You are defined by the changing pattern of relation between you and the world around you. In that sense, learning to think in a shift symmetric way is also a kind of inner training. It trains you to look past surface numbers and ask instead, how is this changing? How does this relate to that? What stays the same when I change my point of view? Those are holophase questions. Before we close, let us bring all of this back down into the rhythm of ordinary life. When you listen to your favorite song played on a different instrument, notice that the melody survives the change. When you scroll through your phone and switch from light mode to dark mode, notice that nothing about the information changes, only the baseline brightness moves. When you add a constant amount of salt to every dish on a table, the differences in taste between them may stay the same, even though all are a little saltier. In each of these examples, there is a uniform shift applied to everything, and yet the pattern of relationships remains. That persistent pattern is what the holophase language calls meaningful. We have traveled quite far in this part. We began with a plane and a map, moved through hills and rivers, listened to music, examined circuits and gravity, and watched the three echoes of time, space, and motion all honor the same simple rule. Only differences speak. We end where we always return, with phi itself. We have not introduced any new substance. There is still one field, phi, and its infinite tower of derivatives. What we have uncovered is a property of that field as a language. Its absolute values are like the choice of font, or the choice of zero on a ruler. They are conventions, not content. The real story lives in how phi changes from place to place and moment to moment. Remember, everything we have talked about is still just one field, phi, and its derivatives, the single language the universe uses to write every story. In episode 8, we are examining this language in its pure, abstract form, before it writes any particular world. In part 1, we met phi as a mathematical creature. In part 2, we met it as pure potential. And in this part, we have seen that its baseline can slide freely without changing any of its stories. We have climbed another branch of the master tree and seen how even the root is defined only up to a shift. In the next part, we will ask why phi lives on a circle rather than on a straight line. And we will see how that circular structure allows for winding numbers, phases, interference patterns, and many of the most striking phenomena of modern physics. We will discover that even the shape of the alphabet matters for what kinds of stories can be written. For now, as you move through your day, try to notice situations where you could change a baseline without altering what really matters. When you turn up the volume on a song, when you dim the lights in a room, when you adjust the thermostat a little while the pattern of your day stays the same, remember shift symmetry. In those moments, you are practicing a new way of seeing, looking past the arbitrary zero to the relationships that remain. Peace be upon you.